Welcome and happy Tuesday, everyone. We just wrapped up our 2022 Oracle Cloud World. Hope you were able to join us live or virtually. If not, you can always go to oracle.com and look for on-demand Cloud World content over there. We've got you covered with that. Now, welcome to the third session of our Day One and Beyond series, which takes you through a series of topics and activities related to building out on Oracle Cloud. For those of you who might be new to these events, we are hosted on Cloud Customer Connect, which is our Oracle community forum for customers and end users. If you're not a member, we invite you to create a free account, join in discussions, post questions, and look for upcoming events on various topics there. My name is Renu Bhatt. I'm a TPM with the Customer Enablement team, and today I'm joined by Olivia Ferda and Joey Hall, both cloud engineers here at Oracle. And really thankful to our content experts, Rafi and Creighton, for joining as well. Today, they're going to cover networking quick start on OCI. But before I hand it over to them, a quick reminder to use the Q&A box down at the bottom of the screen for any questions throughout the session. We will have a Q&A session at the end as well, if we have time. And yes, this session is being recorded. We'll have the replay posted on our community forum. Feel free to share the link with your colleagues who could not make it today. And with that, I'll hand it over to Olivia.
Thanks, Renu. So today we'll be covering the networking quick start and going over some deep dive into some topics within networking and OCI. But before I do that, I'd briefly like to introduce ourselves. So hi, everyone. Once again, I'm Olivia Ferda. I'm a cloud engineer on the customer enablement team. So I've been with Oracle for about 2 years now, and I specialize in operations. And with that, I'll pass it over to our other presenters today to introduce themselves.
Hello, everyone. Thank you for the introduction, Olivia. Renu. My name is Joey Hall. I'm also a cloud engineer on the customer enablement team. I've been at Oracle for about, I think, 3.5 years now, and specializing in security, but looking forward to going through the presentation today.
Awesome, and I appreciate Joey and Olivia, you guys letting me guest today. Creighton Swank. I've worked at Oracle for a little less than 2 years. I am a field CTO aligned to some of our larger manufacturing accounts here at Oracle. I've got some experience with other cloud providers, namely Amazon, as well as kind of building out cloud COEs for large Fortune 50 companies doing data center design and migration. So always looking forward to add some of that color to these conversations and appreciate the opportunity to contribute.
Ditto. Thanks, Creighton. My name is Rafi Shabazian. I'm a principal cloud network architect. Likewise, I've been at Oracle for a little under 2 years now. Primarily, I deal with pre-sales with network design architecture, right, supporting operations. Yet really looking forward to being here today and hoping to contribute. Thank you.
Great. Thanks, everyone. And with that, I will pass it over to Joey to kick off today's presentation.
Perfect. Thank you, Olivia. So as mentioned, this is our networking quick start. So we're running through a series of foundational trainings to cover kind of the broad aspects, broad major topic areas of working within OCI to get you started on your journey within Oracle Cloud. So today we're really going to we're going to go through overviews of the major networking components. We're going to give you an idea of what they are, when to use them, some different considerations for network design use cases. We're going to go into the console, do a couple little demos to show you some of the different tools to make working with networking in OCI a little bit easier. So as we go through these, please feel free to pop questions in the chat and we'll save some time. We'll answer some of them as we go, but we'll save some time at the end as well to cover any of those questions that we did not get to. So with that, we can kick it off. Next slide, please. So the first thing, if you've seen some of our other sessions before, other Day One and Beyond sessions or actual one-on-one enablement sessions, we always like to start our sessions with this slide to give you an understanding of the different responsibilities in terms of the cloud provider and you at the customer when working with any of these different cloud services. So if you're familiar with the typical on-premise architecture, right, we go everything from the physical layer all the way up to user access and identity. That's going to be typically the customer's responsibility. But for these different cloud services, this is going to be a partnership, right, between the cloud provider and you at the customer. So as we work through each of these services from left to right here, you have your infrastructure, platform, and software services, each of which are going to have different levels of both customizability and manageability on the customer side. So when we go through the presentation today, we'll keep in mind for some of these components, let's say you're provisioning a VM, for instance, you're going to have to select the network that instance is going to be a part of, and how some of these components are going to communicate with each other. How do you set up that communication? How do you set up the access for communicating across services as well? So that's all. We're going to keep that in mind as we go through the presentation today.
Awesome. And bear in mind, as you step through those, when you get into the service model, you tend to give up a little bit of control for a little bit of operational efficiency. So as you go down that path, please make sure that you investigate every service in terms of, adoption, to make sure that you know what you're accountable for and what the service provider is accountable for. That's a common mistake customers make, is just assuming the provider, kind of covers all of those things. But sometimes the service configuration can vary. So good piece of advice I always like to throw out there.
Exactly. So yeah, as we go through these, keep the shared responsibility model in mind, and we'll make sure that you are aware of what some of these services are and how you have to consider managing each of these in the different areas which you can configure. And that was kind of from a cloud agnostic standpoint, right? Working with a cloud provider. Here, we're just going to talk about the different services within the cloud ecosystem within Oracle Cloud. We won't spend too much time on this, but as we go through each of these sessions, we're covering different groupings of these services here. So previously, we went over our technical quick start, which gave you overviews of those the core infrastructure components, compute, storage, database. We talked about networking a little bit. That's why we're diving more into it today. So today, we're really just going to be focusing in on that networking piece. And as we talk about how these services can kind of communicate with each other through our cloud network and how we design that network, then some of these other services might be touched on a little bit, but really just focusing in on that networking piece here today. So before we go in and talk about each of these components, so we're going to introduce them here, and then we're going to talk about them in a little more detail as we go through the presentation today and show some of these within the console as well. I guess for Rafi, what are some of the things that customers should consider before they go and actually start to build out their networking architecture and start using some of these components that we're about to talk about?
Right. Really good question, Joey. So some of the things that we really need to think about is the type of architecture model we want to adopt. So for example, are we going to be cloud native? Is there going to be some sort of hybrid connectivity? Do we want to adopt a hub and spoke model, for example? How many VCNs do we want to actually provision, virtual cloud network constructs? Do they need communications with each other? So really establishing that baseline, understanding your current data flows, what new data flows are going to look like, then to really be able to put the pieces together. Address space, is another one. It's huge, I've seen cases where customers over provision, meaning they reserve too much address space, and likewise on the other hand, under provisioning. So there's really a fine balance there. The cloud is meant to scale and grow, but there are all these considerations, and then a slew more to really think about. And it's not just one person has to think about this. These are going to be collective teams, sets of engineering teams that really have to get together and to determine what the proper model is.
Yeah, to jump in on that, Rafi, I think that's one of the biggest challenges is getting, traditional, each one of these components that you see here would tend to represent a separate group within a networking organization, and kind of getting all of those people to talk together and work collaboratively to kind of break down the silos as you move towards cloud adoption is one of the biggest challenges. But I agree, IP address allocation is kind of I think one of the biggest foundational decisions that customers need to make.
And you heard, based off of those recommendations, you heard the term VCN, you heard the term, you have the IP ranges that those ECNs are going to be a part of. We're going to talk about different ways that you can communicate. So as you decide the size of your network, as you decide the type of deployment you're going to do, that's going to determine which of these components you're going to use and how you're going to go about configuring them. So let's talk about each of these components individually, and then we'll dive into this a little bit further. So the first one, which both Rafi and Creighton mentioned, that's the VCN, or virtual cloud network within OCI. So this is that private network that you're going to set up within the Oracle data centers or across Oracle regions. And those networks can be divided up into subnets or sub networks. And within those subnets, you can determine the different type of subnet, right? Regional, availability domain specific, public, private. So just depending on your architecture, you're going to have that ability to configure these subnets. The different gateways, we're going to talk about several different gateways today, just depending on the type of network traffic, the type of communication that you want to establish. So establish communication with the internet, on-premise systems, public OCI services. We'll walk through each of those as well. And then once you have those established, right, you're going to have to figure out how you want to route traffic, how you're going to want to determine how your instances are going to receive that traffic as well. So your load balancer is going to help you distribute that traffic across your instances in a variety of different ways. And we'll walk through some of those different algorithms that you're able to configure as well. DNS, always going to be important when you're talking about networking, regardless if it's within OCI or outside of it. This is going to talk about using the DNS service within OCI to create and manage your DNS zones that you currently have, or creating new ones within OCI. And then lastly, this is just one way in which you can connect to OCI through Fast Connect, but we'll talk about other ways as well, such as IPsec VPN and different types of peering that you could utilize with these different connections.
And Joey, as I mentioned earlier, a lot of these things were individual groups, right? So load balancers and DNS and these things are typically separate services that would have to be built and managed by people. So presenting them as a service kind of really helps lower sort of the barrier to entry of adopting these cloud service. It makes it really easy to consume, even for people that maybe aren't network people. But again, bearing those foundational conversations and decisions are important. But when you build a VCN, you don't have to go manage and provision a bunch of switches and build out OSPF or a number of other protocols between them to ensure redundancy and resiliency. We handle that for the customers to make it easier to adopt.
And when we go into the next piece here for virtual cloud networks, Creighton, you touched about this a little bit. So customers might be more familiar. Olivia, if you would like to go to the next slide, please. Customers are probably going to be familiar working with their on-premise networks, right? And when they go into OCI, they're going to be working with networking. They're going to be working with all these different networking services that they may be familiar with, but it's all going to be hosted by OCI. So what are some other things that they should keep in mind that might be different from working with on-prem that they would have to now work with in the cloud?
Joey, some of the things that we should, and these are essentially pros, right? When working in the cloud versus working, say, in the traditional data center, the flexibility for these types of services. So, for example, VCNs, while you define a CIDR that's static initially, these CIDRs can be redefined. You can add additional CIDRs to them. So they're meant to grow in a very seamless manner. You're able to pivot right around the decisions you've previously made. If you needed to add new subnets on the fly, adjust routing, right, so on and so forth. So it's meant to be more agile and more flexible than your traditional on-premise data centers.
Yeah, and for example, if you go to purchase, appliances, physical appliances that are load balancers, they typically come with a certain amount of rated throughput. In the case of moving to a cloud provider such as OCI, the load balancers are essentially, they have a slider from a configuration and throughput perspective. You don't have to worry about the ins and outs of managing, sort of port densities and switch maintenance and all these other things that kind of come with the burden of managing a large scalable network on premise. We handle a lot of that for you. And, additionally, the only thing that you really need to worry about here is kind of spinning up and how you're allocating them. But a lot of these things are configured with infrastructure as code, so with Terraform templates and things like that. So the ability to provision, kind of standard data centers or containers, however you decide to modularize your deployments, super easy to do just with a Terraform apply command.
Right, so the ability to customize, the ability to expand, adjust these services, right? They're software-defined networks, so they're going to allow you to do a lot of those things a lot quicker and more efficiently than you might typically be used to. So yeah, definitely a lot of pros that both of you mentioned there. And one thing to note, we have this architecture here, just a simple diagram to show you where the virtual cloud network kind of fits in. We're going to be adding components that go along with your virtual cloud network as we walk through this. So you can see we have the virtual cloud network on the screen that's going to reside within a OCI region. So it's a region-specific construct. And if you want to make it more specific, right, we're going to be breaking this down into our subnets. And when you make different components within OCI, when you create a gateway, when you create subnets, when you're actually going to provision your virtual cloud network, if you were watching one of our previous sessions, we talked about identity and access management policies. So before you begin to start building out these components and start managing them, this is likely going to be one of the first things that you're going to be doing when you get into OCI. You just have to make sure you have the appropriate policies for that as well. So you need the policies to create that network, and you also need the policy to manage that network. So just one thing you have to be aware of when you're going in might be different within your cloud environment versus an on-prem environment as well.
Yeah, and defining and creating network resources might not be something you want application developers to do. So the policy is super important there. You want to be able to give that to the people that are accountable for network security controls, and make sure that people that are deploying applications don't have the ability to modify your deployments. And that's all done with policy in OCI.
Exactly. And everything's deny by default at the start. So make sure you're only getting the permissions that are appropriate for those users, like your networking or admin. And then let's talk about how you can actually break these networks up. So we talked about the concept of subnets. So each of these virtual cloud networks, the virtual cloud network address space, but we can break this up into these smaller networks that have different areas of configuration. So you're going to be able to select it being an availability domain specific subnet or a region specific subnet. I think the default is a region specific subnet or a regional subnet. So you could have that subnetwork also span across those availability domains, all three within the region if you're using something like Ashburn or Phoenix, right? Those major US regions there. And then you can also have different areas for configuring security within here as well that I think Olivia is going to be talking upon later, where you have security lists, route tables that'll help define what can communicate with the instances that reside within these subnets, and how do you want to actually enable that communication.
So,
yep, go for it, Olivia.
So Joey, you mentioned 80 specific subnets and regional subnets. Why might you use a regional subnet?
That's actually a perfect question for Rafi. Why would you use a regional subnet over an availability domain specific subnet?
So this is one of, I think, our differentiators here, Joey and Olivia. So we're able to span a sublet across our multiple availability domains. And availability domains are essentially, right, physical data centers that are separate from one another. So this allows us to, right, span that subnet, so to speak. So if we have, let's say /16, it could cover all three availability domains, and we could start provisioning compute resources in different availability domains to achieve, right, a further level of fault tolerance.
Yeah, and traditionally a lot of like enterprise software will rely on moving a virtual IP to failover. And in other cloud providers, that tends to be abstracted with complicated configurations through load balancers. The pattern typically would be like a load balancer sandwich, if you ever heard that before, where you put a load balancer on the front and the back end of that service. In our case, the ability to move a virtual IP across availability domains gives you the ability to move enterprise applications that rely on that clustering technology to failover into OCI without major modifications or complications.
Yeah, no, thanks for adding that, Creighton. And that we see that, right, deployed day in and day out with our different types of architectures we support. So yeah, the floating IP is very key to, right, building your own type of high availability on top of, right, the additional fault tolerance we provide.
Right, and the instances, this is good to note at the beginning here, just from a foundational standpoint, that when you are deploying instances within these networks, right, those instances are going to be drawing their IP address from those subnetworks. So if you have a instance residing in a public subnet, like a load balancer we talked about, or maybe you have a couple instances, maybe your database instance in a private subnet, right, those instances are going to draw their IP addresses from that network. So then when you are establishing different types of connections, when you use things like a security list, when you set up those different types of gateways, right, it's going to be a big component to keep in mind there.
Joey, one last thing to mention with regards to VCN address space. So just supported ranges, we can support CIDRs that are as large as /16s and as little as /30s. So it is, right, quite a big gap there. And in addition to that, we can offer, or we can support multiple additional secondary CIDRs as well.
We also enable IPv6 as well now, correct?
We do. We support IPv6. I don't think it's enabled by default unless you pre-select it during the creation of the CIDR or the subnets.
Right. So let's move on now to the next piece. So one of those components that's going along with that subnet, right, we have what's called a route table. So this is going to determine how you actually are going to route traffic outside of your virtual cloud network. And you can see on the screen here, we're going to have within that route table a destination CIDR and a route target. So if we create a certain component here, if we create an internet gateway, and we want to enable communication through that internet gateway, we're going to have to add a route for it. So you can see here, we added the internet gateway and the destination CIDR to enable traffic flow to the internet here. And we'll talk about these types of gateways here in a second. But one thing to note with the route table is if you actually have communication within the network, within the subnets, within OCI, that communication is going to be handled by the virtual cloud network's local routing by default. So you won't actually have to go in and add routes to the route table for that. That's only going to be for communication outside of your network.
And Joey, just to add on there, so as far as route tables, service limit wise, right, we can support 300 route tables within a VCN, and each route table could support up to 200 route rules. And just recently, we also introduced the concept of intra VCN routing, where you can now actually route subnets from within the same VCN through, say, a firewall, whether it be the OCI network firewall, for example, or a third-party firewall, towards that end device before routing towards the same subnet within the same VCN. Otherwise, that local routing will take precedence.
Oh, more specific routing. I learned something today. Thanks, Rafi.
I did as well. Good to have the network expert on the call, always.
Yeah, it's quite a neat feature. We've already started leveraging it in many production environments. It's working beautifully.
Awesome.
Yeah, and that's a great point, right? Because other cloud providers have similar constraints, right? Where if you end up having traffic inside of VCN, there's really not an easy way, or a VPC in Amazon's case, there's really not a good way to inspect that traffic from an east-west perspective. So this would allow, traffic to be inspected and enforced at a policy level through, kind of your normal enterprise firewalls, whatever your enterprise or whatever you're comfortable with today. That technology could be applied in the cloud now as well with that more specific routing rule.
And then going off of that, we're going to talk about how each of these gateways can help facilitate that communication as well for that traffic outside of your network. So the first one is going to be communication to the internet. And we're going to have two different gateways. As you can see here, you have the internet gateway and the NAT gateway. So the internet gateway, as the name suggests, that's going to provide that path for network traffic between your network and the internet, versus a NAT gateway that's going to enable the outbound connections to your net. So it can make those outbound connections and still receive responses, but it's not going to allow any inbound connections initiated from the internet. So you can see on the screen here, right, we have the public subnet instance within that public subnet. We have that going through the internet gateway for communication. And then we have an instance here in the private subnet utilizing the NAT gateway from some different use cases.
Yep, and just kind of a high-level explanation here. The internet gateway is required to expose public subnets or servers to the internet, right? So if you've got a web tier or something that will be directly accessible from the internet, you'll need a public subnet. In most cases, the NAT gateway would suffice. The NAT gateway would be sort of full-on outbound access to the internet. If you have security policies that control egress, you can certainly send that route to a firewall or a proxy or whatever the case may be. But the recommendation for public subnets and internet gateways in general is be very careful about what you drop there, right? Because when you put something out on a public subnet, it is accessible from the internet. And if you've given it a public IP address, it is available. And so very tight control on security lists and security groups would be important. We would often recommend putting managed service out there instead of a compute instance. For example, a load balancer could be deployed in the public subnet, and your backend web servers could be deployed in a private subnet. Your application would still be accessible. It would just be the load balancer that is a point of exposure and not the servers themselves.
And so,
I'm sorry, go ahead, Olivia.
go ahead, Rafi.
Well, I was just going to add, so we can define one internet gateway and one NAT gateway per VCN, and we're not going to need any more than that. These are highly available and they scale as well. Now, just because we have an internet gateway defined, it doesn't necessarily mean we have a route to the internet. That public subnet would ultimately be associated with a route table that we just covered. And there would have to be some sort of a route rule, whether it's a quad zero or very specific routes pointing to this internet gateway before we can actually achieve that connectivity. Likewise with the NAT gateway, right? The private subnet would have hopefully its own independent, unique subnet route table that it's associated with, and that would have a quad 0 pointing to that NAT gateway object.
So what's a good use case for a NAT gateway? Why would you use it maybe versus an internet gateway? What are some use cases for it that you see with customers?
Yeah, it really depends on which way the traffic is initiated, Olivia. So if we only want egress traffic, a NAT gateway is going to suffice. Essentially, right, all the private resources would need to go out and maybe do some updates, or maybe make some API calls to some other party vendor, so on and so forth. So a NAT gateway is typically going to suffice in that case. The internet gateway, if we need to have resources typically accessed from the internet, inbound connections towards OCI, and that's where you're likely going to house your public load balancers, whether they're application load balancers or network load balancers, and send the traffic off to the backend sets, which could be in private subnets in that case.
Thanks, Rafi. And we're going to go through here. We want to talk about, let's say you don't want to just communicate with, let's say, the internet, but you also want to communicate with other areas. Maybe you want to communicate to on-premise. So there's going to be a different type of gateway that you can utilize to actually establish that on-premise connection. So here we have what's called a DRG, or a dynamic routing gateway, that's going to help provide that traffic between your virtual cloud network and destinations other than the internet. And there's going to be a couple different ways in which you can connect to this dynamic routing gateway. You can see one here. We introduced this at the beginning, right? You have Fast Connect. That's going to be that private dedicated connection that will help you establish connection from your customer data center to the DRG, and then you can establish communication through that. There's also going to be another type of communication, another type of connection that you can make with your DRG. So that would be through IPsec VPN. So you could have that set up as well, and you could utilize redundancy throughout both of these too. So you could have redundant Fast Connects, or you could also set up redundancy through, let's say, using Fast Connect and IPsec VPN. One thing that you'll see is we're mentioning Fast Connect here, and we'll cover that in a little bit later to talk about the different types of connections there with peering options as well. But you might be familiar with the Azure Interconnect, right? So that's another type of connection that's available within some different regions. And I don't know if Creighton, if you want to discuss how, let's say, you would set up that Azure Interconnect connection and maybe some use cases for that for our customers here.
Yeah, for sure. I think one of the important differentiators that OCI has is we're really kind of embracing partnerships with other cloud providers to help customers enable multi-cloud, right? And to do that, our connection, our dedicated circuit is called Fast Connect. Azure has ExpressRoute. One of the things that we've done is we've essentially allowed and partnered with Microsoft to do a cross connect between the clouds. So we call it the Azure Interconnect for OCI, and that is essentially a direct connection between our points of presence and Azure's point of presence. So it's not brought down to your colo and brought back up to add that additional latency. And what it does is it gives customers the ability to access resources in OCI from Azure, or in Azure from OCI, that kind of bi-directional traffic between clouds at 1 to 2 milliseconds of latency with zero data ingress or egress costs. So what that means to you is, you can have resources in both clouds. You can reduce the complexity from an implementation perspective to build that out, because it's done very easily through either the OCI or the Azure console, sort of as a first-party service. We have collaborative support with Microsoft so that, if something goes down, you can open and log a ticket on both sides, and we'll work together on the back end to resolve it. So we give you that ability to kind of leverage services, in either cloud, and also kind of skip that data egress bill that some other cloud providers bring to the table. And in our case, we've expanded that partnership even a little bit more to now allow sort of the direct provisioning of database services within the Azure console. And those services will essentially spin up the backend interconnect and do all the OCI configuration for you, so you can run, autonomous databases directly in OCI and configure, manage, and observe it just as if it were an Azure first-party service.
Right, and that's good to mention when we're talking about this, right? It's communication to resources other than the internet we're talking about here. We're utilizing Fast Connect, and then that's another use case even further expand from here.
Yep, and that would all be routed to and through that DRG, Joey, that you're showing right there. So from our perspective, it's another Fast Connect circuit. It would look like an on-premise connection. It just so happens to be connected to the Azure cloud instead.
Exactly. And we talked about communication to the internet. We talked about communication to on-premise. And now let's talk about one other portion, which is communication to public OCI services. So you can establish connection using what's called here the service gateway. So we can have access to public services like object storage without using something like the internet gateway or the NAT gateway. So that might help alleviate some different, let's say, security concerns that you may have with that. So you can utilize the service gateway to actually traverse the OCI backbone and establish connection to those services for different use cases that you may have here. So here, any of the traffic from that virtual cloud network that is destined for those public OCI services will use the private IP address for routing, so that you don't have to utilize, let's say, a public IP address or put that within an area that would need to utilize something like the internet gateway or the NAT gateway to establish that connection. So here you have some use cases here at the bottom, right? You could back up database systems in your virtual cloud network to object storage through the service gateway.
And Joey, just to add on there, so the beauty of this is, right, these aren't constructs that are just made to be used independently from each other. They're all meant to work with each other. And what I mean by that is, a slide ago, we were talking about the dynamic routing gateway and fast connect connection towards your on-premise data centers, right? That dynamic routing gateway has a very special function. It's your virtual router. Now, what we could do essentially is we could also take VCN route tables that we talked about and associate them with that service gateway and that DRG. And now we could access object storage through your private virtual circuit, through the fast connect, through the DRG, through the service gateway to ultimately reach your traffic that otherwise your data center would have used your public internet to route to. Now, there's other ways of achieving this with fast connect using public peering, which I'm sure we'll talk about later. But if we're talking about a private peering through the DRG and we leverage VCN route tables and associate them with that service gateway and that DRG, we can now have that traffic flow through your dedicated connectivity instead of going through the internet to reach object store, for example.
And we do cover that in a couple slides indeed, so we can dive into that in a little bit more detail. So the next piece, we're going to talk about local peering and remote peering, and then we'll get more into fast connect and we'll talk about public peering and private peering. So a couple things going on here. So here, if you want to communicate to other virtual cloud networks, right, you have two different types of peering options here. We have local VCN peering and remote peering. I know Creighton's going to talk here in a second about how this process is going to be slightly different than what you see on the screen here. But let's say you wanted to communicate within virtual cloud networks that span or that reside in different regions, right? Because our networks are those regional constructs within OCI. You could utilize one of those gateways that we just talked about, the dynamic routing gateway, to establish that remote peering connection. With local peering, you can see what's called a local peering gateway, but that process is actually changing with additional features with the DRG that, Creighton, I don't know if you want to highlight that in a little bit more detail and let customers know kind of the new way in which this should be handled.
Yeah, absolutely. I think one of the important things is that, the DRG has been enhanced. We call it DRG v2. In the console, you'll see DRG. It's dynamic routing gateway. It allows multiple attachments to VCNs now. So the traditional way to connect VCN A to VCN B, or in this case, 1 to 2, would have been a local peering gateway. And that's set up on both sides. You add the peering gateway, you establish a peering relationship, and is very much a one-to-one connection. Super easy to manage if all you have is 2 VCNs. But if you have 20 VCNs, you have to build this weird complicated mesh of, one VCN connecting to 19 others and then them connecting back. So at scale, that got fairly complicated. When you move to the DRG v2 now, which any DRG that you deploy in the console now will be a DRG2 DRG, you can basically then just multi-attach and let the DRG manage traffic between your VCNs. So the picture would look very similar. You'd still have a DRG that would connect your fast connect and your IPsec if you have that, but that same DRG then would attach to 10 to 15 other VCNs or however many you have in that region and allow traffic to pass. You would basically then send all traffic. The route rules would be all traffic out of VCN 1 would go to the DRG, and then you'd let the DRG determine, if that traffic's going to go on premise or if it's going to go to another VCN. So it really does simplify the operations of kind of multiple VCNs within a single OCI region.
So allowing it to work at scale much easier and be easier to manage those different connections.
Absolutely. That's the huge benefit there is getting rid of that mess of having to manage 20 individual peering connections across the board, and troubleshooting that if something were to go wrong is, as someone who's had to do that before, it's never a good time.
Happy we're resolving that. Thanks, Creighton. And now I'm going to pass the next portion of the presentation over to Olivia, and then I will come back for the demo here at the end. So Olivia, off to you.
Thank you, Joey. So this next portion, we're going to be talking a little bit more about VCN security. So you can use VCN security rules to restrict network access to instances. So whenever you're creating a security rule, you have to state whether it's stateful or stateless, because by default, it is going to be stateful. And stateful just indicates that you want to use connection tracking for any traffic that matches the rule. So for instance, when an instance receives traffic matching the stateful ingress rule, the response is tracked and automatically allowed back to the originating host, regardless of any egress rules. And then stateless just indicates that you do not want to use connection tracking for any traffic that matches the rule. So it just means that response traffic is not automatically allowed. So real quick, Rafi or Creighton, why might you use a stateless rule or a stateful rule? Would you use stateless more for like high performance applications? Like why would you use one over the other?
Rafi, yeah, go ahead.
Yeah, no, thank you, Creighton. Olivia, I think you nailed it. Stateless rules are typically going to be meant for high performance applications that are typically public facing, usually HTTP, HTTPS type of traffic, to be able to limit the latency for all those connections coming in. Stateful rules otherwise are recommended. We do want to make sure we account for that return traffic. So those would be essentially the use case for the stateless rule.
Yeah, and I'll say from a more of a server admin perspective, stateful rules are much easier. The challenge with stateful rules is that you have to have something managing the state. So if you're building and managing those firewalls, it becomes important to set up, super low latency connections between the primary and the failover, so that if something fails, that moves over. In this case, all the onus on managing that state is on OCI. So as a consumer, I would probably default to stateful rules and run stateful rules 100% of the time, because truthfully, in the customer's perspective, like you don't have to do the heavy lifting there, and you're putting all the hard work and all the overhead of that management onto the service provider, which in our case is us. So from that perspective, I would tend to shy away from stateless rules because they're a little bit more complicated to manage.
So in a case where like the network traffic matches both stateful and stateless security lists, the stateless rule will still take precedence over the stateful rule?
From an evaluation perspective, I think precedence becomes a little bit of a misnomer. So the way that these rules are evaluated is it's the union of the rule set. So be it a security list or a security group, we add up all the allowed, and if it's allowed in any of them, the traffic is allowed through. So from that perspective, if you hit the stateful rule first, the traffic will flow through. If you hit the stateless rule first, the traffic will flow through. I think there would actually have to be two separate evaluations, one for the inbound and one for the outbound traffic for the stateless rule. So I would hope that the stateful rule would take precedence. But Rafi, you might know for sure if that is the case.
Yeah, I believe it's the stateless rule takes precedence over the stateful rule within the security list. So with that said, you'd need the corresponding reverse rule for the egress direction in that security list to account for the stateless rule taking precedence.
And any firewall admins in the audience are cringing about potential asynchronous routes and rule evaluations right now.
It becomes really cumbersome to manage, and this is why stateful rules are going to be recommended.
And so the networking service also offers two virtual firewall features that both use these security rules to control traffic at the packet level. And so that is the security list and the network security group, which I'll cover in this next slide. So security list, this is the original virtual firewall feature. So it consists of a set of ingress and egress security rules that apply to all the VNICs in any subnet that the security list is associated with. So this just means that all the VNICs in a given subnet are subject to the same set of security list. And so you're also going to have network security groups or NSGs. And these can be more granular in terms of security and can be used with or without security lists. So it just lets you define a set of security rules that applies to a group of VNICs of your choice. And so just to give you a use case or an example of how you can use the two of them. So let's say right here, we have these two servers in the same subnet in OCI. And if we want all these servers to permit SSH on port TCP 20 or 22 or something like that, then we can use a security list associated with the subnet containing these servers to have an entry to permit the SSH. So you can use a security list for that. But if you only want one of these servers to allow ICMP, then an NSG is needed where you include only the VNIC of that one server. So once again, that NSG lets you get a little bit more granular, and Oracle recommends using NSGs for components that have all the same security posture.
And I think this is what Creighton was mentioning earlier, where if you are utilizing both, then it's going to be the union of the two. So if you're allowing in one, it's allowing in both. Is that correct, Creighton?
Yes, it is. And that's something that is very different from how other cloud providers evaluate their rule sets. Like the parity here on AWS would be security or NACLs versus security groups. And NACLs are only stateless, but they are sort of evaluated holistically, right? So typically you see NACLs that are allow all on the outbound, and then you add additional traffic from a security group perspective. Like you want your instances to be able to talk out, you need something to be able to talk in. In our case, if the rule is allowed anywhere, there's no precedence or order in that space, so it would be allowed. And that could also affect, the way that you place your instances from a subnet perspective. So maybe you want to put all of your web servers in a web server subnet, or an application servers for app one in a dedicated subnet based on the exposure of those needs to kind of go down that path. So all of these factors come into kind of how you're going to design your VCN tenancy. But yeah, absolutely. That's one of the big things that I think customers need to be aware of, because it's a risk to reward thing, right? It's if you don't know it, you could accidentally expose something that you intend not to.
So now that we've covered security rules and how you can use security lists and network security groups, I want to next jump into load balancers. This is just going to provide automatic traffic distribution from one entry point to multiple servers reachable from your VCN. And so you're going to have things like health checks to ensure that the load balancer directs traffic only to healthy instances. And you're also going to have algorithms, so you can define the policies that tell the load balancer how to distribute incoming traffic to your backend servers. And so there's three different algorithms that you can use, or different load balancing policies. And so there's round robin, there's least connections, and there's IP hash. So the first is round robin. So this is going to be the default load balancer policy. And this just distributes incoming traffic sequentially to each server in a backend set list. And then once each server has received a connection, the load balancer repeats in the same order. So for instance, on this slide right here, like 1, 2, 3, 4. So then once it's gone through 1, 2, 3, 4, then I'll go back again and go through 1, 2, 3, 4. And this is going to work best when all your backend servers have similar capacity. So that is going to be round robin. You also have least connections, and this routes incoming non-sticky request traffic to the backend server with the fewest active connections. This just helps you maintain an equal distribution of connections to your backend servers. So you can also assign a weight to each backend server to further control how that traffic is distributed. So once again, like if this only has 3 connections, this has 2 connections, this has 1 or 0, you can, it will route to the one with the fewest active connections. Once again, you can kind of assign, a weight to each backend server to further control how that is going to be distributed. And then lastly, you also have IP hash, and this uses an incoming request source IP address as a hashing key to route non-sticky traffic to the same backend server. So that load balancer routes traffic requests from the same client to the same backend server as long as that server is available.
Yeah, and there's a lot of configuration options here, but realistically, it's flexibility to provide compatibility with backend application sets. If you have an application that doesn't care about app state, like it's a simple microtransaction, a microservice API-based application that's in and out, one transaction and done, it doesn't really matter with respect to stickiness and ensuring that your sessions get routed to the same backend targets. But if you have larger enterprise applications that maybe don't store centralized state information, but leverages them as part of the connection or that individual state, you need to make sure that the traffic comes back to the same backend server to avoid interruptions to service. So realistically, these are all configuration options, and the right configuration options would largely be driven by the type of application that you're running.
So there's an application load balancer. What about the network load balancer? Why would you use?
The network load balancer would primarily be for any application that's not HTTP or HTTPS. The application load balancer is a little bit more layer 7, and Rafi, please step in and correct me if I misstate anything here, but it would be more protocol aware, right? So we talk about exposing applications to the internet. Your SSL termination would absolutely be done on the application load balancer, but it can only speak HTTPS on the front end. A network load balancer could be used to provide access to other non-standard ports, like we'll say directory services or any like SSH, things like that. So one of the common patterns I see for a network load balancer is like an SFTP based integration where you put the network load balancer up front and have a server behind it that would be the actual SFTP target to do that connection termination. So basically anything other than HTTP. The other benefit to a network load balancer is that can do IP-based targets. So you can actually load balance things that would be on premise or maybe even in other clouds, as long as that load balancer has a path to that. I've also seen network load balancers used to get around sort of IP conflicts across VCNs, so that you provide kind of essentially a proxy service at that layer.
Yeah, definitely, Creighton. Sorry, and just to add, right, network load balancer, it operates at layer 4. It can preserve your true client IP, your true source IP. Application load balancers, they operate at layer 7. So meaning the connections will be proxied to the backend. It's not a one or the other, right? We have several mature architectures that we leverage network load balancers in the front, for example, load balance to a pair of virtual appliances, network virtual appliances. It's meant to handle millions of flows. And from the network virtual appliances, we then can go back to a private application load balancer hosting your web tier and app tier.
Gotcha. Thank you. Right, so going a little bit more into how the load balancer service works. So there's going to be two kinds of load balancers. There's going to be a public load balancer and a private load balancer, but let's just first talk about the public load balancer. So when you create a public load balancer, you have to select 2 availability domains for the load balancer to reside in. So in this case, we'll see that this load balancer, the active one, resides in 81, and then we have the failover one in 82. And because OCI is going to create 2 copies of the load balancer to make the service highly available, you're going to need to have 2 subnets, and it's either going to be a regional subnet, which is recommended, or 2 availability domain specific subnets. So in this case, we'll see that this is a regional subnet. And then after creation, the public load balancer sits at the edge of a VCN. And then what happens next is there is a primary load balancer selected automatically to hold the public IP, and a secondary load balancer in an active/standby configuration. And then next we have a listener right here. And this is the public IP address and the service ports that are opened up to sit between the internet and your backend servers. So in case one of these ADs goes down, the listener will fail over to the other AD automatically. And this is where we see a dotted line at the top will be the new path for traffic. So that high availability is built in. You don't have to manage that high availability. It's all managed by the service itself. And then the second type of load balancer is going to be a private load balancer. And it's going to be, the implementation is going to be a bit different. So 2 copies of the load balancer will go into a single subnet. And so just want to note that if an AD outage occurs, a private load balancer created in a regional subnet within a multi-AD region is going to provide failover capability. But if you have a private load balancer created in an AD specific subnet or in a regional subnet within a single AD region, that's going to have no failover capability in response to an AD outage. But however, other than this, all the other capabilities are going to be the same. So next portion is DNS zone management. So DNS stands for domain name system. And it's just an internet system that maps human readable names like oracle.com to IP addresses. And so this DNS zone management just enables you to create and manage your DNS zones. So you can create zones, add records to zones, and allow OCI's Edge network to handle your domain's DNS queries. So Rafi or Creighton, what are some benefits of using DNS?
Well, DNS is one of those services that's kind of foundational for a lot of, application infrastructure. And so customers, when they move workloads to the cloud, they'll kind of make the decision in terms of where DNS is going to be hosted. And so from that perspective, leveraging, kind of the capabilities that we provide from a DNS perspective on the front end is kind of a non-negotiable, I'd say, right? Like you don't want to force all that traffic to come through your on-premise environment because we have some advantages with respect to failover and time to live for zones that we control. So at a very minimum, anything that's publicly facing and publicly accessible, so like app.company.com, you'd probably want to delegate that zone directly to our DNS so that if you want to do the cool things like, dynamically update zones and kind of move things around, then it becomes a little bit easier to do more dynamically with API calls in OCI. But Rafi, I don't know if you've got thoughts there with respect to kind of other benefits, but I know we scale, obviously that's going to be one of the big benefits, but I think it's more the interaction that is important.
Yeah, Creighton, I think you managed to cover all the important things there. So yes, highly scalable. It's very mature service, right? Highly configurable. There's private views to manage the DNS views for, say, all your attached VCNs. We have forwarding endpoints, listening endpoints where you could send, on-premise queries to us and we can resolve oraclevcn.com. We could forward to on-premise for any one of your, company.com domain names. So it is easy to manage and scalable and highly available.
So I know we only have a few more minutes left. Joey, would you like me to cover some of the last few slides, or would you want to go ahead and jump into the console?
So we kind of covered the following slides a little bit when we talked about Fast Connect and the different connection types and the peering options. So I think it might be beneficial to show everybody the console with the time that we have left.
Sounds good. I'll pass it over to you, Joey.
Thank you. Give me 1 second. I got to sign back in. I'll be fast.
And Joey, while you're signing in, I think there was a question about certificates. Do we provide CA signed certificates for our load balancers and endpoints? We do not. However, you can certainly upload your own certificates and manage it that way. Otherwise, we also have a certificate service that lets you create and manage certificate authorities, certificates, and CA bundles as well. So hopefully, Ramon, that answers the question. Sorry, I was going to type the answer in, but I accidentally clicked go live or answer live. So I don't think I can type to that anymore.
It's faster that way too, so that works. Thanks, Rafi.
Thank you.
So here we are going to hop through a quick demo just to show you a couple of the tools that make working with networking in OCI a lot easier, a lot quicker. If you've seen a couple of our presentations before, we gave an overview of the OCI homepage, but for now, we're just going to hop into the networking section. So as with all the different services, if you don't have a quick link that you've already pinned, or it's not within the quick starts or quick launch areas, right, you just navigate to this top left menu here, head down to networking, and you can see all of these different networking components that we talked about today. So the first one, we talked about virtual cloud networks, and when you're going to establish or you're going to create a virtual cloud network, you have two different options for creating that network. So you can create the VCN, and then once you create that VCN, you can go through and create each of those components individually that you want to be associated with your virtual cloud network. Or you could use what's called the Start VCN Wizard. So our VCN Wizard actually makes this provisioning process a lot easier, a lot faster, and you have a couple different types here as well, or different, depending on the connectivity requirements, right? You could use either of these wizards. So here you can see it'll give you a quick diagram of the components that will be created with this VCN wizard. So you have your network, you have your public subnet, private subnet, route table, security lists, each of those gateways here. So you have your internet gateway and your NAT gateway. You can see the inbound and outbound connections. You can see the outbound connection here. And then also the service gateway to connect to Oracle public services. If you need to add internet connectivity and site-to-site VPN connectivity, you can select this option. You can see we have the DRG that's going to be provisioned as well. So just depending on what your requirement is, we talked about that as a main consideration or something to consider before you actually go and create these is what's your actual use case? What are you trying to connect to with your network? So you have both of these options. And if you started this wizard, this just shows the quick configuration. There's those components one more time. You give it a name. Each of these is going to sit within a compartment. So your virtual cloud network and all of those components, those are all going to be resources that will be grouped within compartments. So again, compartments are going to be those logical resources that you're going to use for that access boundary when you're giving access to these resources. So your network's also going to be a resource that you will be controlling access to. You have your different CIDR block ranges that you have the ability to adjust. You can change your public subnet, you can change your private subnet, and you can also edit these afterwards once this has been created. But really simple. You go in here, let me just give a name real quick. Test day 1 and beyond. I think that might need an underscore. And then you would hit next, and you could review all of the different components and create that. And then you can go and edit those as well. So you have your security lists, route tables, all these. You can see the default rules for each of them, ingress, egress, each of the subnets. Same goes with your route tables. So here I already have a network created that we actually used the wizard for. So I'm just going to cancel this real quick and I'll show you that network. And instead of showing you the details of the network from the actual provisioned VCN itself, I'm actually going to go to what's called the network visualizer, because that's a much cooler way to look at your networking components. It's actually very useful as well to see what's actually going on within your network, what's connected to what, how are the routes from each subnet moving. So if we go in here to the network command center, you can see this network visualizer tool. So if you've created your network, make sure you're in the right compartment because that's where your networking resources are going to be stored or grouped. So here it's just going to load this network map quickly, and you can see that VCN here with the associated attachments. So you got the internet gateway, we have the service gateway, and we have the NAT gateway. So that was that first option that we had with that VCN wizard. And if you go in, you could click and you could go into the actual VCN to view some of those components. And you could double click in this as well, or double click into, let's see, either the VCN routing map or the VCN security map. So if I wanted to go into something like the routing map, you could see the routes between your, so using the route tables and the subnets. So you could see here, each of those gateways, you have your overall network, and then you have your subnets within here, right? So we have a demo subnet, private subnet, right? That's going to be your NAT gateway and your service gateway. We have a database subnet, and we have the public subnet. So then you have that is going to be connected to the internet gateway. If you can go in here, right, you could actually view the subnet inventory. So I could see what's within each of these. I think we have a load balancer within our public subnet, and we have our instances in our private subnet. And I'll just show you this real quick, and then we can end and answer maybe 1 or 2 more questions. But I just wanted to show you this as a good way to navigate your network and get an idea for what's going on. So here you could actually see the instances within your network. So you can see we have this test instance, we have one of our web servers, and our second web server here as well. So this one's actually stopped for now, but you can see the status of those. And as with any section within the network visualizer, if you want to go in and start configuring any of these resources, editing them, right, you're going to have the name is going to be clickable and will take you into that instance here. And we viewed it from the route inventory, right? So we went from the route table perspective, but you could also go back and view the security list from the same view as well. But really cool tool. I use this all the time when I'm trying to figure out what's going on within my tenancy. It just gives me a better visual for how my network's actually set up. So I wanted to show you that here as well. And I guess we could do a couple more questions if we want. We could call it here, or we could hop into the resources at the end to show for labs and stuff. So what are we thinking? Were there any unanswered questions that we could quickly touch upon here at the end?
There are a couple in the Q&A. One of them centers around recorded session, and that, I don't know, Renu, if you can talk about where that will be.
I'll send the link again. I'll share it in the chat.
Awesome. Thank you. And then I think we see, so the network arch diagram that we're talking about here would be confined within the tenancy. So the Balaguru, the question that you're asked here is kind of that really is sort of the intention of the network visualizer. Rafi, are there ways to pull and unite network visualizer diagrams from multiple tenancies, or would that be confined within that boundary?
I think you're right, Creighton. It's confined within that boundary, but yeah, ultimately, I think the vision is to, right, be able to produce something like that. Yeah, I wish I had a better answer.
No, that's fair, and I think that kind of boils down to also the age-old tenancy discussion, right? When customers come from maybe like AWS, for example, they assume that there needs to be multiple tenancies to be set up. But the way that the OCI cloud is architected, compartments provide a lot of that segmentation. So for most customers, we see one tenancy that kind of handles them all. So Balaguru, from that perspective, I think Network Visualizer could give you that visibility across the confines of the tenancy. But sort of the visualization would stop when you leave the OCI tenancy. So that would include things like your on-premise network or other cloud networks if they exist.
Thank you, Creighton. Thank you, Rafi. I know we went a little bit over on time, but we had a lot of good discussion, a lot of good additions from our experts here today. So hopefully we got through everything that people wanted to see, and we have another session up and coming next week. That is going to be the operations quick start. But we would like to thank you all for joining, and we have a couple different links and resources that we can offer to you to kind of further your learning past these sessions. So when the deck is sent out, you'll have the links for those here as well. And we'll try to get those follow-up questions out to all of you as well after the session.
Thank you. This is awesome. Thank you so much, Olivia, Joey, and a big thanks to Rafi and Creighton for helping us answer all those questions and making these discussions so interesting and giving away all the good information out there. Really appreciate your time and help with the session, and a big thanks to everyone for joining us today and staying late as well. It's been 5 minutes over the hour. Our next session, like Joyce mentioned, is next Tuesday on November 1st, where we'll focus on cloud operations. Believe me, you don't want to miss that session. So go ahead and register now. I'll share another link right away. You can use that link to register for the next session. Thanks again for your time today. We'll see you all next time. Have a great day, everyone.